Hello everyone, welcome to my YouTube channel. Today we'll be talking about the factor of a polynomial. Okay, so it's popularly known as the factor theorem. All right, factor theorem. All right, so what is this um, theorem talking about? Well, it's all about factor. So what is a factor? Well, a factor is a number that divides another number without a remainder, right? So in terms of polynomials, let's say you have a polynomial x cubed minus 5x squared plus 8x minus 4, okay? And then you are going to divide this by x minus 2. So if you haven't watched my video on division of polynomial, I suggest you pause it here, go and watch that video before you continue. Because when you actually divide what we have here by this, your answer should be x squared minus 3x plus 2. Okay, now there is no remainder, so that means that x minus 2 is a factor of x cubed minus 5x squared plus 8x minus 4. Okay, the fact that there is no remainder when it divides it, that means it's a factor. Okay, so if it is a factor, then that also means that if I put, let's say I'm going to define this polynomial as p of x, okay, is equal to this. Okay, so if this is indeed a factor, then that means when I put, if we are arguing that, let me use a red color to circle this. If we are arguing that this is a factor of this polynomial, then that means p of 2 should be 0. Okay, that when I put the value here 2 into the polynomial, I should get 0. But before we even continue, this is what I want you to do. Always set the factor to 0. Okay, so you see x minus 2 equals 0, that means x is equal to 2. Okay, that is why I'm saying that the polynomial 2 should give me 0. All right. Okay, so let's verify that. So if I have p of 2, then I'll have 2 raised to the power 3 minus this square plus 8 into 2 minus 4, and definitely this gives 0. You can verify that. So that is what factors are about. So sometimes you'll be asked to show that's a factor by long division. It means when you divide, there shouldn't be any remainder. Or you can be asked to use a factor theorem to verify that a particular polynomial is a factor of another polynomial. You understand? Okay, so now let's solve some examples to see how all these are played. So the first example, so example number 1, we have x minus 4. So let me actually write a full instruction. It says that use the factor theorem to show that x minus 4 is a factor of x cubed minus 3x squared minus 6x plus 8. Okay, so what do you do? Solution. Since we are talking about factor theorem, what the theorem says that if this value here is indeed a factor, then when we substitute x equals 4 into this equation, we should get 0. Okay, so first set the factor to 0. So x minus 4 equals 0. It means x is 4. Now you let's maybe say h of x Okay, anything that you want be equal to the polynomial that you've been given. All right. If this is the case, then you are going to argue that h of 4 must be 0. So let's verify that. So h of 4 will be equal to 4 cubed minus 3 into 4 square minus 6 into 4 plus 8. Okay, now if that is the case, let's do it one by one. So 4 to the power 3, that should give us 64. Then 4 to the power 2 is 16. 16 times 3 is 40, so we have negative 48. Then we have 6 times 4, that is negative 24. Then we have plus 8. Okay, so let's see, 64 minus 48, that should give us negative 16. Then we have negative 24 plus 8, that should also give us, sorry, this is not minus 16. This is actually positive 16. Okay, and this is minus 16. So that means our answer is 0. Therefore, x minus 4 is a factor of s cubed minus 3x squared minus 6x plus 8. So this is how you go about it, right? The first thing you want to do is to make sure that you set the divisor to 0 so I can solve for the value. Once you have the value, you put that into the function, and if the answer is equal to 0, then it means that x minus 4 is indeed a factor. So this is one way to go about it. Sometimes you'll be given the polynomial all right, but some of the variables or the constants or the coefficients, anything could be missing, and then you'll be asked to find it. How do you do that? So that will be our example 2 in this video. So for example 2, we have, say, says find the value. So find the value of E in the following. Okay, in the following. Okay, so our first case is x plus 1 is a factor of 6x squared plus 27 6s cubed plus 27x squared plus ax plus 8. So clearly we must look for the a, okay, but they have already made a claim that this is a factor of this polynomial. So let's go ahead. So if it's a factor, then we expect that x plus 1 should be equal to 0, so that x is equal to negative 1. So we can say p of x, let p of x be equal to the polynomial in question. All right, ax plus 8. So that means that p of negative 1, this negative 1 that we have found, okay, if we put into p, our answer should be 0, since it's a claim that's a factor. All right, so that means p of negative 1 will be equal to 6 into bracket negative 1 cubed plus 27 into bracket negative 1 square plus e into bracket negative 1 plus 8 should equal to 0. Well, negative 1 cubed is still negative 1 times 6 is negative 6. Negative 1 square is positive 1 times 27 is 27. A times negative 1 is negative a plus 8 equals 0. Alright, so at this stage, what you want to do is just do negative 6 plus 27 plus 8, and that should give you 29. Okay, so you have 29 plus 29 minus a equals 0. So this implies that a is actually equal to 29. Okay, so this is how to go about it. They can make a claim that this is a polynomial, it's a factor of this polynomial, so find the value of a. Then this is how you go about it. Let's talk about one more example whereby two of the coefficients are missing. Let's say 27 is also missing. So this is a, this is b. So it'll be like find the values of a and b. Okay, so that should be our last example. So let's say example number 3. All right, so we want to find the value of a and the value of b in the following, okay. All right, so we have x squared plus 3x minus 10. The claim is that this is a factor of what do we have? X cubed plus ax squared plus bx plus 30. Right. So now we have a quadratic which is a factor of a cubic. So the first thing you want to do is to take the quadratic and equate it to 0. Okay, you are looking for the roots of the quadratic. So you have x squared plus 3x minus 10. Right, so let's factor this. Let's say it's equal to 0. All right, so we have so x plus and minus. Okay, this is negative 10. Factors of negative 10 when added to give 3, that will be 5 and negative 2. All right, so that means you have x equals negative 5 and then you have x equals 2. Great. So now you are going to work in two cases when x equals negative 5 and x equals what? 2. So let's say that polynomial is p of x. So we have p of x is equal to x cubed plus ax squared plus bx plus 30. So let's start with the first case. We want to argue that p of negative 5 should be equal to 0. Okay, so let's put negative 5 in each case. Negative 5 cubed, negative 5 square, negative 5 plus 30 equals 0 because it's a factor. Okay, all right. So, well, negative 5 raised to the power 3, that should be negative 125, right? So negative 125. Then 5 squared is 25, so we have 25a. And that should be negative 5b, and then we have plus 30 equals 0. Alright, so this will imply that, let's group some like terms here. So we have 25a minus 5b should be equal to, well, if you have negative 125 and then you add 30 to that, you should have negative 95. And then you transpose it so that it becomes positive 95. Right, so you might want to simplify this. 5 goes here 5 times, this is 1s, and then 95 divided by 5, that should be 19. Okay, so let's call this equation 1. So the next thing we want to do is to put 2 into the polynomial and then set it to 0, and we will find another equation. Then we solve the two equations simultaneously for the values of a and b. So now let's do this. P of 2, right? So that means we have 2 raised to the power 3, and then we have plus 2 square plus b into 2 plus 30 equals 0. Alright, so this will imply that you have 8 plus 4a plus 2b plus 30 equals 0. In other words, we have 4a plus 2b is equal to negative 38. Alright, so we can simplify 2 here. This is 2. Now 38 divided by, negative 38 divided by 2 will give you negative what? 19. So negative 19. Let's call this equation 2. Right. So you have equation 1 and equation 2. So let me write both equations down here. This is for equation 1, and you have 2a plus b equals negative 19, equation 2. So it will be easier for you to add the two equations up, because that will give you an opportunity to eliminate the b's. Okay, so when I add them up, what I do have is 7a is equal to 0. A definitely must be 0. Now, if a is equal to 0, then that means that choose one of the equations. So let's say we are working with equation 2, which is 2a plus b equals negative 19. So if a is equal to 0, then we can easily find for b, and that means that therefore b will be equal to negative 19. So we can rewrite our polynomial very well. Remember, we were given this polynomial, and now we know the values of a and b, so let's just put them there. A is 0, b is negative 19. So what that means is that therefore the polynomial is now x cubed plus, this is 0x squared because a is 0, b is negative 19, so we have minus 19x, and then plus 30. This simplifies to become this minus that plus 30, and then you are done. So this is how to use factor theorem to look for the values of a and b.